Alright, in this video I'm going to look at another example of a higher order derivative, a second derivative, but this one involves a circle, so we're going to use implicit differentiation. So the question says determine, so this is y double prime, so that's kind of just shorthand for the second derivative, right? So that just means d squared y over dx squared. So second derivative of this function. So the way we're going to do this is using implicit differentiation. So if you remember, implicit differentiation means you take the derivative with respect to x of both sides of the equation. So basically it's a d by dx of both sides. So on the right side it's just that constant 16, and on the left side it's x squared plus y squared. So on the right side, that's easy. D by dx of 16, that's a constant, so the derivative of a constant is always just 0. Now on the left side, you've got to use your sum rule, so it's d by dx of x squared plus d by dx of y squared. The first one's usually the one no one has problems with, d by dx of x squared, that's just your power rule, so that's 2x. Plus, and then it's d by dx of y squared. So remember, you're differentiating a function of y with respect to x. So you gotta think about that as a chain rule. It's 2y, which is your power rule, but then you need to multiply by the inside derivative, and the inside function here is y. You have to think of y as a function. So the derivative of y is dy by dx. Okay, so to get the first derivative, we're just going to isolate for dy by dx. So 2y dy by dx equals minus 2x. You can divide both sides by 2y. So the 2's will divide out. So dy by dx equals minus x over y. So that is your first derivative. So in order to get the second derivative, we have to take the derivative of this. We don't need to, well, I guess we will do it implicitly because there's an x and a y. But you're just going to take, so the second derivative is just the derivative of this. So in order to do that, you're going to have to use the chain rule. So sorry, not the chain rule, the quotient rule. The quotient rule states take the derivative of the numerator. So that's minus 1 times the denominator minus the numerator times the derivative of the denominator, but the denominator is a function of y, but we're differentiating with respect to x, so that's going to be dy by dx. Or you could say 1 times dy dx, all divided by the denominator squared. So that's, what is that? So it's minus y plus x dy by dx all over y squared. Now what's a little different here is you've got this dy by dx in your equation. So what you're going to do is you're going to make a substitution. Remember up here we said dy by dx is minus x over y. So we're going to take minus x over y and substitute it in for dy dx because that's what dy dx equals. So minus y plus x times, and then remember it was minus x over y over y squared. So that simplifies to minus y minus, you're going to multiply this, so it's x squared over y, all divided by y squared. If we get a common denominator on the numerator, we're going to have a common denominator of y. We'll have to multiply the y by y, so minus y squared minus x squared. And then that's all divided by this, by y squared. Just to kind of make my life easier, I'm going to, instead of dividing by y squared, I'm going to multiply by 1 over y squared. So now I don't have a fraction inside a fraction. I'm just multiplying by a second fraction. So the numerator, if I multiply numerators, I'm going to have minus y squared minus x squared. And the denominator, I'm going to have y cubed. Now in the numerator, what I'm going to do is, notice I have two negatives, so I'm going to factor a negative. And I'm just going to flip the order, so I'm going to write x squared first. So it's going to be x squared plus y squared, all divided by y cubed. And that's, like, it's pretty good. That's basically what we've got. The only thing I can do here that does make it a little simpler is, notice here I have x squared plus y squared. Remember the original equation. So the original equation was x squared plus y squared equals 16. It was a circle. So let me just write that down here at the bottom. So remember the original equation said x squared plus y squared equals 16. Well, I've got x squared plus y squared right there. So I'm just going to take the 16 and substitute it for x squared plus y squared. So this is equal to negative 16 over y cubed. That's d squared dy dx squared. So that's the second derivative, and that's as simple as you can get it. Okay, so just a comment, when you do this implicit differentiation, like, it might seem kind of like a coincidence that, like, it's simplified to x squared plus y squared and we were able to go back to the original equation and substitute the 16. It's not. Anytime you're doing an implicit second derivative, you're always going to be able to make that substitution. So just watch out for it, and at the end it should simplify, so you can substitute, like, part of the original equation in to make things a little bit simpler.